Hi, I'm Jordan. I'm an engineer here at Nuon, and today I'm going to walk you through supporting a shared responsibility model with a BYOC app. Now, supporting shared responsibility might sound like it would add a lot of complexity, but Nuon makes supporting this scenario just as easy as if you control the entire stack from top to bottom. I'm going to show you the entire process from beginning to end. I'm going to show you how to configure the app. I'm going to show you what the customer experience is of installing the app. And then I'm going to switch back to the developer experience for a bit to show you how you can monitor the app even though you don't control the environment it's running in. So yeah, let's get the show on the road. We're going to start with the developer experience. We're going to configure a simple ECS service. And let me actually show you ahead of time what that's going to look like. So I'm going to go to our developer dashboard. And here I have an install I set up ahead of time. You can see I've named this My BYO VPC app. So this is an acronym we use sometimes to mean bring your own VPC. This is a common scenario where a customer wants you to install the app inside a VPC they've already configured. And I've got two components here, a Docker image, which bundles a simple API, which you'll see in a minute, and then an ECS service, which creates not only an ECS service, but also an ALB and an ACM certificate, so we can handle HTTPS traffic. You can see that both of these are running on top of our ECS BYO VPC sandbox. So this is a sandbox that's practically identical to our regular ECS sandbox, except instead of creating a VPC itself, it expects to be given a VPC ID to install itself into. And what does that look like? If I go over here to Amazon, so this is what that install looks like through the Amazon console. This is the VPC. I set this up ahead of time completely outside of the Nuon platform. So the Nuon platform itself had no prior knowledge of this VPC's existence, doesn't know anything about it. The only thing I had to do ahead of time, and if I click on one of these subnets, I can show you what this looks like, is add some tags so that we know which subnets are public and which ones are private. This is technically optional though. Our sandbox is configured to do this by default, but if for whatever reason your customer doesn't want you to use these tags, you can fork the sandbox and customize this as well. And then if I go over here, I can show you the ECS cluster we've created. And I have two services here. I have the API, and then I have our install runner, which is managing the install for us. So I'm going to click on the API, and I'm going to show you that this is running in that exact same VPC that I just showed you a minute ago. And so that's the basic idea, right? Even though this component was built completely outside of the VPC and was not placed here by the owner and manager of the VPC, it's still running just fine. You can see that it's logging. Give these a minute to load. There it is. You can see that we have an ALB with a target group that's hitting this health check to make sure it can route traffic. And if I go back to terminal, I'm going to open this API, and you can see it's serving traffic. So this is just a basic introspection API that we created for demo purposes. This endpoint right here is just showing us the environment variables that are set. I believe if I remove that, you can see all the other endpoints it supports. So it's just a nice tool that we use sometimes to kind of look at the state of an install from the inside. So yeah, now I'm going to show you how I set all this up. So I'm going to start by installing the CLI. We recommend doing this via Homebrew. Of course, we do also have an install script that you can use for Mac OS and most Linux distros, and we do make the binaries available for download. So once this is done installing, all right, there we go. I'm going to log in. Now, obviously, I already have an account, but if you don't, one will be created for you at this point. And now that I am authenticated, I'm going to select our demo org. So this is an organization we have internally for demos just like this. If you don't already have an org, you can run Nuon orgs create, and an org will be created for you. And in the background, that will provision the infrastructure management server as well as the build runner, which will be used to create the builds you'll see later in this demo. You don't need to wait for that to happen though. It's just going to happen asynchronously in the background. So now we're going to create the app. So I'm calling this my awesome Bring Your Own VPC app. This command is doing two things. It's creating the app in our platform, and it just finished. And then it's also creating this right here. So this is a config file that we're going to use to configure our application and add components. So let's open that. And so here you'll see a bunch of default content. We put this in here just to show you what you can do in this file. Today we won't be using any of this. Instead, I'm going to go to the written version of this guide, which you can find on our doc site at docs.nuon.co. And I'm going to copy some of the sample code we have here. Also worth noting, we do have a Terraform provider, and everything I'm doing in this demo you can also do with Terraform instead of our config file. We have sample code for that in this doc as well. So I'm going to start with an app input. So this is important for a BYO VPC app. What this is going to do is expose a setting to the customer so that they can give you a VPC ID to install the app into. And then we're going to add our installer, and this is where the setting will be shown. You'll see what that looks like in a minute. I'm going to update this slug because it does need to be unique. Let's see, awesome BYO VPC app. Okay. And then I'm going to add our sandbox. So this is kind of the main event for this tutorial. You'll notice here, instead of our regular AWS ECS sandbox, I'm using our AWS ECS BYO VPC sandbox. And as I said earlier, it's practically identical. The main difference just being that it will not create a VPC for you and expects to be given one. And just remember that it does require ahead of time that you put those public and private tags on the subnets because it needs to know which ones are public and which ones are private so it can provision ALBs and services in the right subnets. Right. Before I move on, almost forgot to mention, you'll notice that I'm passing the VPC ID here as an input. So this is how we get the VPC ID from the setting that will show the customer on the web page to the sandbox when it's being provisioned inside the install. So finally, I'm adding the runner. And this is just our typical AWS ECS runner. We use the same one, whether you're running the ECS sandbox in your own VPC or a different one. It doesn't really care. It just cares that it's running inside an ECS cluster. And at this point, we should be ready to sync our config. So this is going to read that config file, and all those settings I just added, it's going to apply them to the Nuon platform. It's going to create that installer page, and it's going to tell the app which sandbox to use and which runner to use. And this does take a few seconds, but when it's done, we'll be ready to start adding components. Okay, so there we are. Before I move on though, I am going to select this app, and this is just a convenience we have in our CLI. By selecting the app, I don't have to keep passing that app name to every command I run. And all of my commands will be run in the context of this app going forward. So now we're going to add our components. So I'm going back to the written version of this guide. I'm going to copy this Docker image. So this is what bundles the API I showed you earlier. And what this is going to do is tell the Nuon platform to build the Docker image and then sync it to the install on deploy. And it's going to store it. The install is going to store it in its local ECR registry. And then I'm going to copy this ECS service. So this is a Terraform module, and as I mentioned earlier, it's creating the ECS service, it's creating an ALB, and it's also creating an ACM certificate. Now, a few things to note here. I am telling it which cluster to install into. That's going to be interpolated during the deploy based on the installs data. I'm telling it which image and tag to use. These will also be interpolated during the deploy. And they're going to be derived from the deployment of this Docker image up here. And then I've got a few other config things I'm adding just for interpolation purposes, just so we can sort of show off data in the API. And then finally, I'm telling it what VPC to install into. It's worth noting that when you create an ECS Fargate cluster, because it doesn't provision any compute resources by default, it's not technically a VPC resource. It's the services you provision inside the cluster that need to be told what VPC to run in. So this is something you have to do here. If you're using EKS or regular ECS, you shouldn't have to do this. But it's worth noting that when you're using Fargate, there is a bit of a unique thing here you have to handle. And finally, we're giving it some information about where we want the API to be hosted underneath the installs domain. So at this point, we should be ready to sync again. And now it's going to read that config file, and instead of updating the app, it's going to create those two components, and then that's going to kick off initial builds for both of those components. So this can take a few seconds, but when it's done, we will see, there it is. We will see the components via the CLI. So those have been created. And then we're going to see those two builds. Now these are still building, but we don't have to wait for those. As I mentioned earlier, the Nuon platform handles asynchronous dependencies for you, so we can just move along. Anything that depends on those builds being there will essentially queue until the builds are ready. Okay, so now we're going to move on to the customer experience of installing the app into a VPC. So I am going to open that installer page we configured earlier. Here it is. And if I scroll down, you can see that we have 3 different ways to install this, right? Now, if you have a customer who likes to manage things with Terraform, we support that. If they would like to create the IAM policies manually, we support that. But the easiest thing to do is use our CloudFormation stacks. We publish one of these for each of the sandboxes we support. And what this does is create an IAM role with all the required permissions to provision that install and get it up and running. So I'm going to click on this option. And because this is an account that we use to demo a lot of stuff, to avoid namespace collisions with this IAM role name right here, I'm actually going to copy this app name. Your customer doesn't have to do this, although they can if they want to. And if they have a bunch of stuff running in their AWS account already, it might be a good idea. That way they can ensure that they don't step all over anything they already have installed there. So I'm going to do that. And then we're going to create the stack. Now, while this is creating, it should only take a few seconds. There it is. So now I have an IAM role. I'm going to go to that IAM role, and I'm going to copy the ARN right here. And I'm going to go back over here and paste that into this field. All right, so that's the ARN we need to be able to provision the install. But because this is a BYO VPC install, we also have to pass in a VPC ID. So I'm going to go back over here to this VPC. I'm going to copy this. I'm going to paste that right there. So now our install is ready to go. It has the permissions it needs, and it knows what VPC to install into. And I'm also going to tell it to install in US West 2 because that's the region I happen to be using for this demo. And I'm going to hit go. Oh, and I do need to give my company a name, so I'm just going to call this Jordan's Cool Startup. And it's off and running. So yeah, as a customer, I'm done. I can go get a cup of coffee or something, and by the time I get back, this should be up and running, and I should be able to hit the API just as I showed you earlier. So now that the customer has launched that install, let's switch back to the developer experience. And I'm going to show you how you can monitor the install even though you don't control the environment it's running in. So I'm going to go back to that developer dashboard I showed you earlier. Oh, and you'll see there's our new install. So this updates in real time, and you can see it's running. You can see some information about it. So these deploys haven't happened yet because the sandbox is still provisioning. But you'll notice that this looks exactly like any other install would in this dashboard. Just because it's running inside of someone else's VPC, that doesn't change your ability to monitor it, create releases to update it, and make changes to the components. It's all exactly the same. So that's basically it from beginning to end. So yeah, thank you for your time, and I hope this was useful.